Friends, now today we will see why the pendulums are used. See now, there is a much more importance in the value of acceleration due to gravity, and the Galileo was the first person who have performed in 1590 a spectacular experiment of dropping a cannon and a musket ball from the Leaning Tower of Pisa. And see, by this he has been clearly showed that at any given place all bodies, they may be big or small, when dropped so as to fall freely, do so at the same uniform rate, neglecting of course the resistance to their motion due to air. Therefore, the value of G differs from place to place, being the greatest at the poles and the least at the equator. Its a value for all practical purposes is however taken to be 981 centimeter per second square in a CGS system and 9.8 meter per second square in SI system. See friends, due to this large value of G, bodies fall much too quickly to the surface of the earth when dropped freely, and hence it becomes difficult to measure its directly with any great accuracy, and due to what it is therefore determined indirectly with the help of a simple or compound pendulum or the other pendulums. See now, one thing is here cleared, why these pendulums are used. Means the pendulums are used to determine the value of acceleration due to gravity. Now see, there are pendulums, simple pendulum, then bar pendulum, then Ketter's pendulum, again Borda's pendulum, and all these extra, etc. But here we have to see what are the drawbacks in previous studied pendulums. Means that what is the drawback, or what is the simple pendulum? Simple pendulum, by its definition, it is nothing but a point mass suspended to a rigid support by means of inextensible and weightless string. See friends, by the definition we cannot take a point mass, and we cannot take in practice inextensible and weightless string. Therefore, whenever we are going to measure the time period for the simple pendulum, it does not having a much accuracy, and therefore there was another pendulum which is known as a bar pendulum. Again, bar pendulum is nothing but a metallic or a brass strip, and holes are drilled at equidistance on the bar. Again, there is one problem, that the holes drilled on that bar are not perfectly perpendicular to the plane of the paper, and therefore when it is supported to a rigid support, it wobbles, and wobbling of that pendulum is directly affected, we can say, to the oscillation of the pendulum. And therefore, again, to overcome the drawbacks of simple pendulum and bar pendulum, there is another pendulum that is nothing but, now we are going to study of that is a Ketter's pendulum. See, the pendulums having the interchangeability of means not all the pendulums, but particularly this we are talking about the bar pendulum and Ketter's pendulum. The interchangeability of center of suspension and center of oscillations is one of the important thing, by which means that this is nothing but an important property, that is, if we have been seen the time period for the center of suspension and center of oscillation is equal one, which is the same as the center of suspension and center of oscillation, and therefore means it is nothing but the time period t is nothing but 2 pi under root of L plus k square by L by Z. This is the same for center of suspension and center of oscillation, and thus we can say that the centers of suspension and oscillations are interchangeable. They are reciprocal to each other. This is nothing but the property of pendulum. Firstly, this property was put forward by Huygens. See now we came across today's our interesting or very simple again to discuss about the Ketter's pendulum. This Ketter's pendulum is nothing but one of the type of a compound pendulum. It consists of a brass or a steel bar. Brass or a steel bar AB is visible from the diagram. A and B is a steel or a brass bar. See, B is nothing but a heavy bob. This B is nothing but a heavy bob, and F1 and F2, this F1 and F2 are nothing but the knife edges to suspend the pendulum to the rigid support, and W1 and W2 in this diagram, this W1 and W2 are nothing but the cylindrical wooden weights which are smaller than the B, and in this way W2 is smaller than W1. See now, it see the knife edges mutually facing towards each other, which is in the diagram shown by F1 and F2 near its two ends, so that the pendulum may be suspended from either two cylindrical weights, which is shown in the diagram W1 and W2. They can be made to slide along the length of the bar and clamped in the position desired the small weights W2. These are all weights having a micrometer screw. M is a micrometer screw to slide or to make a fine adjustment. The position of the CG or center of gravity of the pendulum can be altered by changing the relative positions of the two weights, their positions being, however, so chosen that the center of gravity always lies in between the two knife edges. See now, for performing the experiment with the Ketter's pendulum to find out the acceleration due to gravity, the pendulum is first suspended from the knife edge F1, which is shown in the diagram, and its time period is determined. It is then suspended from the knife edge F2, and for this F2 again the same process, its time period is determined. It is then suspended from the knife edge, determined again across the F2. If there is a divergence in the two values of the time period, the heavier weight W1, this heavier weight W1 is moved up or down and a proper position found for it, so that the time period is, it must be very nearly the same whether the pendulum be suspended from F1 or F2. The smaller weight again W2 is then adjusted by means of the micrometer screw M until the time period in the two cases are as nearly equal as possible. See, then when this is so, we have obviously one knife edge at the center of oscillation of the other. The distance between the two knife edges again means the knife edge F1 and knife edge F2. Distance between two knife edges is measured carefully. This gives the length L of the equivalent simple pendulum. This length L of the equivalent simple pendulum, and the value of G is then calculated by the relation, by the formula G equal to 4 pi square L by T square, where T is the mean of the time period about the two knife edges. In this way, friends, we are able to find out the acceleration due to gravity by using Ketter's pendulum. Thank you.